Hi friends, uh, let me give you some idea about how to calculate the molecular mass of polymers. So our topic is about calculating the molecular mass of polymers. Although not very prominent for JEE, sometimes there are few questions asked on this. So there are two types by which you can calculate the molecular mass. One is number average, number averaged, averaged molecular mass represented by m with subscript n, and the other way of calculating molecular mass is weight averaged, weight averaged molecular mass, and we represented that with w in the subscript. Okay. So let me first start with the idea of what is the number average, number average molecular mass. Okay, this is how we represent this. Right. Now here we need to consider if if we have n1, n2, n3 and so on, which are the number of molecules with different molar masses, different molar masses m1, m2, m3 and so on, then we define this average, which I wrote this as mn bar is equal to n1 m1, n1 m1 plus n2 m2 plus m3 m3 and so on, and that we could divide it by n1 plus n2 plus n3 and so on. Okay, so you could see this is more of an average. Got it? So where we have n1 different types of molecules of molar mass m1, n2 different types of molecules of molar mass m2. So this way we can have a polymer made, and we can find the average based on this particular data. Okay, so this is how we can calculate the number average data. Similarly, if at all we had to calculate the uh, weight average, so weight average molecular mass, which I represented as mw. Now how do we calculate this? For which again I need to consider if I had m1, m2, m3 and so on are the masses, of species with molar mass, molar mass m1, m2, m3 and so on, then I can represent this m, which is weight average, is equal to m1 n1, m1 m1 into m2 m2 plus m3 m3 and so on, divided by m1 plus m2 plus m3 and so on. Okay, so or I could simply write this as summation of mi divided by summation of mi, right? But we do know that mi, which is the mass, can be represented as number of atoms or molecules into its molecular mass, right? So therefore, now I can write mw is equal to summation of mi square, because I'm substituting mi here, so that would be equal to ni mi divided by summation of ni mi, right? So when we substitute this here, Ni is the number of molecules of molar mass M1. Got it? So this is very important relation, students. So you could see this is how we can identify. So we can identify the average molar mass in terms of its weight. Got it? So these two formulas are important. Just me revise that. First one is this one, and the second one is this one. So these are the two formulas which we'll be using. Got it? Another important term which we need to learn from this chapter is what is that PDI index, which is polydispersity, polydispersity index, written as PDI. Right? What does this mean? It is the ratio of weight average molar mass or molecular mass to the number average molar mass, number average molecular mass. Okay, so by definition itself, it's very clear that it has something to do with the ratio of the above two which we learn. So PDI, okay, so let me write down that again. So PDI will be equal to MW, which is the weight average molecular mass, divided by MN, which is the number average molecular mass. Okay, so basically it gives the idea about homogeneity of the polymer, homogeneity of the polymer. Okay, that's the whole idea. We get it from PDI here. Got it? Now, if we have PDI equal to 1, that means this is equal to this, right? Then we could say it is more homogeneous, or we call it as monodisperse polymers. So let me put down more terms when it comes to the value of PDI as if the case is. So case 1 is if PDI is 1, okay, which means Mn will be equal to Mw. So in this case, all the molecules nearly have same molecular mass, right? So polymers which are forming by these molecules have same molecular mass, all right? So we call this kind as monodisperse polymers. Okay, so these are the monodisperse polymers. So similarly, let me write down case 2 here. If PDI is greater than 1, which suggests that Mw is greater than Mn. So in this case, this would have molecules with wide range of molecular masses. Okay, so it would have wide range of molecular masses. Okay, and these kind of molecules, these kind of polymers, we call it as, okay, these kind of polymers are known as polydisperse polydisperse polymers. Okay, these are the two important terms. Well, then we have case 3, which suggests if PDI is less than 1. Well, this case 3 is a hypothetical case, so it is hypothetical. So we will not be discussing about this case. So as of now, we have seen two things: monodisperse polymers and polydisperse polymers. Okay, and the other important factor we need to remember that Mn, which is the number average molar mass, is calculated experimentally using colligative property, like osmosis. Okay, so there could be simple multiple correct questions asked that how we calculate the molar mass or the number average molar mass. Similarly, MW, which is the weight average molar mass, is usually calculated by experiments like light scattering or ultracentrifugation, ultracentrifugation or sedimentation, etc. So these are different techniques by which you can calculate Mn and Mm. Now, polymer in increasing order of their intramolecular forces, if at all I say, right, you know that, just a note you can have it, that increasing intramolecular forces, increasing intermolecular forces, okay, that is polythene. Polythene would have would have less interactions than Gona S, less than nylon 66. Okay, so this is a basic understanding of what is PDI, what are monodisperse, what are polydisperse, and so on. Okay, so the next important part in this is how do we calculate uh, the how do we calculate the degree of polymerization? So let me put down that here. So how do we calculate something called degree of polymerization? Okay. So before we deploy with any technique, first I want to take one example. Now imagine CF2, CF2, and N. This is a polymer called Teflon. Okay. Now if you see the monomer here, right? So the monomer is actually CF2 and CF2. So therefore, the molecular mass, I'll write it as MO, which is of monomer, as how much? 12 twos plus 19 fours. So that makes it around 100. So the monomer, so the molecular mass of the monomer is 100. Now imagine if the molecular mass is already given. So usually it is the number average molecular mass. So if number averaged molecular mass molecular mass is given, we should write it as Mn. For this example, let me take some value, maybe some 120,000. This is how much it is given. So in that case, degree of polymerization would be equal to Mn, which is the molar average molecular mass of the entire polymer, divided by the molecular mass of the monomer. So that makes it degree of polymerization. So it would be 120,000 divided by 100. So that makes it 1200. So that is the degree of polymerization. Let me take a simple question here. It says if a polythene sample contains two monodisperse fraction in the ratio of 2 is to 3 with degree of polymerization being 100 and 200, then its weight average molar mass will be how much? So the question is, we need to calculate uh, weight average molar mass given DOP of a polymer, one kind of a sample here. In the sample, one kind of a polymer DOP is given as 100, so which I can write it as molecular average molecular mass of one particular sample divided by its monomers molar mass, right? So from here I could get the average molar mass or weight average molar mass of DOP will be equal to 100 times of MO1. Similarly, I can write the MW2 second polymer in that sample as 200 MO2, correct? So this is what we need to know first. And also he is given that the monodisperse fraction is 2 is to 3. That means for every 2 moles of one type of polythene we have, uh, there would be 3 moles of the other. So that means uh, polymer 1 polymer 1 would have 2x moles or 2x number of uh, polymers, and polymer 2 will have 3x number of polymers. Got it? So it's more like this is that N1 and this is N2. So we have learned earlier how to use the formula, right? So we know that mean of mass average molar mass will be equal to, right, N1 mi square integral, right, Ni divided by summation of Ni mi. So I'll be using the same formula here. So these are the given conditions. So I hope you can see that. So for example, based on this, if at all I put it MW1, MW1 is given as 100 MO1, MW2 is given as 200 MO2, and N1 is given as 2x, N2 is given as 3x. So the mean of all will be equal to N1 into MW1 square plus N2 MW2 square divided by N1 MW1 plus N2 MW2. So substituting these values, I'll get 2x into 100 MO. Okay, this is the same monomer, so I don't have to worry about this 1 and 2 actually. So it's the same, which is polythene. So 100 MO square plus 3x into 200 MO whole square divided by 2 into 100. So how much is this? 2 into 100 MO plus 3 into 200 MO. Okay, so we could see that here this 2x actually, sorry, 2x and 3x. So I can see, you can see the x can be taken as common and that get cancelled. So I'll have 2 into 10 raised to the power of 4 MO square plus 3 into 4 into 10 raised to the power of 4 MO square, that divided by 200 MO plus 600 MO. Okay, so when you solve it for this, and one important information which we need to know, that MO, which comes from polythene is CH2 N times, right? So the monomers molar mass would be 14 into 2 plus 4 into 1, so that makes it 28 plus 4, which is 28 plus 4, sorry, 12 into 2 plus 4 into 1, so 24 plus 4, which makes it 28. So the mass of that monomer is 28, so therefore this all get cancelled, so I'll have 10 raised to the power of 4 coming out. Sorry, 10 raised to the power of 4 coming out, so I'll have 2 into 28 square plus 12 into 28 square, and that divided by 10 raised to the power of 2 into 2 into 28 plus 6 into 28. Okay, so this, when you solve, you would get MW average as 4900. Okay, so this is how we calculate the uh, averaged molar mass given the compound and different information.